Hello everyone. I'm Evidence Ma'am.
And I'm Stats Bro.
This channel is for studying quick and comprehensive medical statistics. Let's have fun together and improve our statistical literacy. Today, we'll be studying what quartiles are and how they are used. Let's start with the conclusion. First, the interquartile range, IQR, is the range between the 25th and 75th percentile values. Second, the IQR is a measure of variability that is independent of the data's distribution. Third, Box-and-whisker plots can be used to summarize the distribution of data. Now, let's take a closer look at each of these points. As a quick review of the previous video, when representing measures of central tendency for data with a normal distribution, we typically use the mean. For data with skewed distributions, we use the median. And when indicating measures of variability in the data, for data with a normal distribution, the standard deviation is often used. So, what do we choose as a measure of variability for data with skewed distributions? That's what we'll be learning about in this video, the interquartile range, IQR. So, what exactly is the interquartile range, IQR? In a nutshell, it can be described as the range of the middle 50% of data when arranged in ascending order. To be more specific, it's the range between the 25th percentile and the 75th percentile values. Let's illustrate this with a diagram. When you arrange data from minimum to maximum, the middle value is known as the median. In other words, there are 50% of the data above and 50% below the median. Among the lower 50%, if we find another median, that becomes the 25th percentile value, also called the first quartile. Similarly, among the upper 50%, finding the median gives us the 75th percentile value, also called the third quartile. This middle 50% range, from the 25th to the 75th percentile, is what we refer to as the interquartile range, IQR. It's a simple and intuitive concept, isn't it? The key takeaway here is that, as I mentioned earlier, the interquartile range, IQR, has a close relationship with the median, just as the standard deviation has with the mean. The standard deviation pairs well with the mean, and the interquartile range, IQR, pairs well with the median. If you're not familiar with standard deviation, I recommend checking out our previous video. Now, let's consider how to use this interquartile range, IQR, in practice. The IQR is a measure of data variability, much like the standard deviation. In technical terms, it's often referred to as a measure of dispersion. While the standard deviation excels when dealing with data that follows a normal distribution, it can be less useful for other types of distributions. On the other hand, the IQR can be applied to data without regard to its distribution. Similar to how the median works, it provides a reasonable summary of data, regardless of the distribution. A common way to summarize data using the median and interquartile range, IQR, is by using Box-and-whisker plots. In a Box-and-whisker plot, data values are plotted vertically, and the box and whiskers represent different aspects of the data's distribution. The central box in the plot represents the interquartile range, IQR, itself. The top of the box corresponds to the 75th percentile value, while the bottom represents the 25th percentile value. Inside the box, a line is drawn, which corresponds to the median. Now, what do the whiskers signify? In fact, there's a bit of variation in how whiskers are defined. But generally, the upper whisker represents the maximum value within 1.5 times the IQR above the 75th percentile. I know this might sound a bit confusing, but essentially, you place another box on top of the original box, extending it 1.5 times the IQR. The maximum value within this extended range becomes the upper whisker. If data points fall beyond this range, they are typically considered outliers. The lower whisker works similarly. You place another box below the original box, extending it 1.5 times the IQR, and the minimum value within this range becomes the lower whisker. Data points below this range are treated as outliers. When outliers are present, they are individually plotted outside the whiskers. So, box and whisker plots can have two visual patterns, with outliers and without outliers. The focus here is on the pattern without outliers. In this case, there are no data points outside the extended range above the upper whisker. This means the upper whisker simply represents the maximum value itself. This makes it much easier to interpret when there are no outliers. Now, let's practice interpreting a box and whisker plot. Imagine you have data on the weights of 20 individuals, and the box and whisker plot looks like this. What can we deduce about the distribution of these 20 individuals? First, the box represents the interquartile range, IQR, which corresponds to the middle 50% of the data. The line inside the box marks the exact median, and the bottom and top of the box represent the 25th and 75th percentile values, respectively. Since there are no outliers in this box and whisker plot, the maximum weight among these 20 individuals is 100 kilograms, and the minimum weight is 30 kilograms. That's the explanation. Now, let's tackle a practice question. Here's the question: A has a maximum value of 211. What do you think? That's correct. Since there are no outliers plotted, we don't need to worry about the 1.5 times the IQR range. However, keep in mind that the way box and whisker plots are presented can vary, so always check the accompanying explanation below the figure when reading them in real research papers. Now, let's move on to the second question. Here it is: in Group A, there are 3 times as many data points that are 100 or more compared to Group B. What do you make of this statement? Let's analyze it. In Group A, the lower whisker extends beyond 100, indicating that at least 75% of the data in this group is 100 or more. On the other hand, in Group B, the upper whisker stops at 100, suggesting that only 25% of the data exceeds 100. Since both Group A and Group B have the same sample size, the answer to this question is indeed correct. Now, for the final question. The statement is: within the data of Group A, 50% of the values are larger than the maximum value in Group B. What's your assessment of this statement? Among the data in Group A, the upper 50%, above the median, can be seen as the range we're interested in. In Group B, where there are no outliers, the upper whisker represents the maximum value. Comparing the upper whisker of Group B with the upper 50% of Group A, we can see that the statement is false. How did you do? You've now become quite proficient with box and whisker plots. If you felt that we went a bit fast, feel free to rewind the video and review the content. Lastly, let's take a look at how the interquartile range, IQR, is used in actual research papers. In randomized controlled trials, when comparing control and intervention groups, you often see tables that look like this. In these tables, you'll frequently find notations such as median, IQR. As I mentioned earlier, the median and IQR go hand in hand. Just as the mean and standard deviation are closely related, the median and IQR work together to provide a brief summary of data's central tendency and variability. By presenting both, you can summarize a dataset in a single phrase. So, to summarize, the interquartile range, IQR, is the range between the 25th and 75th percentile values. The IQR is a measure of variability that is independent of the data's distribution. Box and whisker plots are useful for summarizing the distribution of data. That's all for today. If you found this video helpful, please consider subscribing to the channel. Your support motivates us greatly. Next time, we'll dive into the most crucial concept in medical statistics, inferential statistics. Please stay tuned. Until then, see you again soon.